differentiation of tan x and tan inverse of x. F of x equal to tan x, then f dash of x will be equal to secant squared x. The same way, if f of x equal to tan inverse of x, then f dash of x will be equal to 1 by 1 plus x squared. Now let us see how to apply this. Suppose if y equal to tan 3x, then dy over dx will be equal to tan x, differentiation is secant squared x. So secant squared 3x, and then this 3x we differentiate, so we get a 3. So we write that in front. So differentiation of tan 3x is 3 secant squared 3x. Suppose if y equal to tan inverse of 3x, so dy over dx will be equal to 1 over, instead of x we have a 3x. So it is 1 over 1 plus 3x the whole square. And this 3x when we differentiate, it is multiplied by 3. So it will be equal to 3 over 1 plus 9x squared. F of x equal to tan inverse of 0.5x minus 1. Now f dash of x. So instead of x, we have this entire expression of 0.5x minus 1. So now we'll write it as 1 over 1 plus 0.5x minus 1 the whole square. So when it is an x, it's x squared. So this expression squared. Now differentiate this 0.5x minus 1. So it will be equal to into 0.5. When we simplify this, we can just write it as 0.5 in the numerator divided by 1 plus 0.5 minus 1 the whole square. This 0.5 is nothing but it is a half. So it is 1 by 2 into 1 plus 0.5x. 1 plus 0.5x minus 1 the whole square. So this will be our y equal to 3 tan inverse of x over 10. If it is like this, then dy over dx will be equal to 3 is a constant. So we write it as it is 3. And this one is 1 plus x by 10 the whole square. And then when we differentiate x over 10, we get it as 1 over 10. So this can be written as 3 in the numerator, and this 10 goes in the denominator. So denominator 10, and this one we can write it as 1 plus x squared over 100. If you can just leave it like this, or if we want to simplify further, so it is 3 over 10 into 100 plus x squared over 100. We are taking the LCM for it. So it becomes 100 over 100. Now this 10 and this gets cancelled. So it will be equal to this 10 multiplied in the numerator. So it is 30 over 100 plus x squared. This is the simplified way of writing the answer. The fifth question, f of x equal to x tan inverse of x minus 0.5 ln 1 plus x squared. So when we see here, this is a product. Here there is an x and tan inverse of x. So it is in the form of a product. But this is a normal expression. So for this alone, we'll apply the product rule. The product rule is, suppose if y equal to uv, then dy by dx will be equal to u into dv over dx plus v into du over dx. That is, we keep the first expression, differentiate the second. Then keep the second and differentiate the first. The same thing we'll apply it over here. So f dash of x, keep the first expression x, differentiate tan inverse. So it will be 1 by 1 plus x squared. Then plus, keep this tan inverse, the second expression, keep it, differentiate the first expression. So minus, this one is 0.5, and then ln of x is 1 over x. So it is 1 over 1 plus x squared. Then differentiate this, so multiplied by 2x. So now we simplify this. This is x over 1 plus x squared plus tan inverse of x minus this is half. This half and 2 gets cancelled, so it will be x over 1 plus x squared. Now x over 1 plus x squared and x over 1 plus x squared, we can cancel it. So our answer will be equal to tan inverse of x. Sixth question, f of x equal to tan inverse of square root of x minus 1. So f dash of x will be equal to 1 over 1 plus square root of x minus 1 the whole square multiplied by this differentiated. So this can be written as x minus 1 to the power of half. So when we differentiate it, it is half into 1, x minus 1 to the power of minus half. And then again when you differentiate the bracket, it is 1. So we are not going to make any changes. So it will be equal to 1 over 1 plus. This one is x square root of x minus 1 the whole square is x minus 1 only. Square root and the square gets cancelled. So it will be x minus 1. This will be multiplied by 1 by 2 into square root of x minus 1. So plus 1 and minus 1 gets cancelled. So the answer is 1 by 2 and an x is over here. 2x into square root of x minus 1. The seventh question, y equal to 1 plus x squared tan inverse of x. So now this is again a product. 1 plus x squared is one term and tan inverse of x is another term. So it will be dy over dx will be equal to. Now this one when you write, keep the first term as it is. Then differentiate the second term. So 1 by 1 plus x squared. Then keep this plus. Then keep the second term, tan inverse of x. Then differentiate it. So it is 2x. So this and this gets cancelled. So it will be 1 plus 2x tan inverse of x. The eighth question, y equal to tan inverse of x by 1 plus x squared. This is in the quotient form. So it is y equal to u over v. Then dy over dx will be equal to square the denominator, write the denominator, differentiate the numerator, du by dx minus u into dv over dx. This is the quotient rule. Now we are going to apply that for it over here. So now the numerator is u. U is tan inverse of x and v is the denominator, so 1 plus x squared. So du over dx will be equal to 1 over 1 plus x squared. dv over dx will be equal to 2x. So now our dy over dx will be equal to square the denominator, that is our first step, square it. Then write the denominator, that is v into du by dx. So this way first. So 1 plus x squared into 1 by 1 plus x squared minus, and then this way, tan inverse of x into 2x. Here, don't multiply this 2x with x. This x is an angle. This is a number. So be careful. Don't multiply this number with the angle. So this will come as this and this gets cancelled. So it is 1 minus 2x tan inverse of x by 1 plus x squared the whole square. So we can differentiate tan x and tan inverse of x using the quotient rule and the product rule. Thank you.